Hello everyone. So my name is Viraj and we'll be looking at the editorial for the Leetcode Contest 386 in this video. Alright, so let us start discussing the problems. We have problem 1 that is named split the array. Alright, so let us read this. You are given an integer array nums of even length and you have to split the array into two parts nums1 and nums2 such that there is an important condition nums1 dot length is equal to nums2 of length and they both are equal to half of the original array's length, right? Now second condition is nums1 should contain distinct elements and nums2 should also contain distinct elements. Alright, so this is clearly given to us. Now they have said that return true if it is possible to split the array and false otherwise. Alright, so if we look at the test cases, they have said true for the first case. Why? Because let's say you have the number 1 and 1 coming, you can give this 1 to the first array and you can give this other one to the second array. So 1 goes here, 1 goes here. Now you have 2's, so 1, 2 to this array, 1, 2 to that array, and everything good looks right up till here. Now you have a 3 and a 4. So you can take this 3 and you can give this to the first array and 4 can be given to the second array, right? And for the second case, this becomes a false answer. Why? Because if you try to split this out, you will be given 1 to the first array, the next one to the maybe second array, but now you will again encounter a 1 over here. And because of that, you are bound to give this one to either nums1 or nums2. And if you do that, nums1 will not have distinct elements anymore. And if you give it to nums2, nums2 will also not have distinct elements anymore. Correct? So we can directly return false from here, that yeah, this is not a correct answer. Alright, so how do we approach this question? So pretty simple, right? There are going to be simple looking cases, right? I have case 1, right? I have case 1, I have case 2, and I have case 3, right? Why have I created cases? Because the whole question is kind of relating to the frequencies of the numbers coming in the array nums, right? And I'm trying to divide them up, either giving it to nums1 or giving it to nums2. So I have created cases, and what will these cases denote? These cases will denote is if, let's say, I am talking about the element value x, all right? So let's say I have the element value x and the frequency of that number x in the nums array turns out to be f. So I'll make these cases on the basis of f. I'll say if f, this is the frequency, or fx actually, I can say maybe frequency of the element x. If fx is greater than 2, then you need to return false. False, right and right from here. Why is that? Because you know very well that let's say some number in the nums array is coming out to be has the frequency greater than 2. That means 3, 4, 5, so on. So because of that, what would happen is you would give one such looking x number to, let's say this was nums1, all right, this was nums1, and similarly this was nums2, correct? So you will make the target that, all right, let me give this number x to one place over here, and after this, because you know you still have the frequency greater than 2, that means there are still some occurrences of x, and you will be forced to give those occurrences to either nums1 and nums2. And if you do that, you will be left with no other choice so as to violate the condition that either a nums1 will now have duplicate elements or nums2 has duplicate elements. So there is no way possible to distribute or to create an answer true if any number in the array has a frequency greater than 2. So case 1 becomes, if frequency of x is greater than 2, I need to return false. Else, if fx is equal to 2, meaning if the frequency of that particular x number turns out to be equal to 2, then what do I need to do? Makes simple, right? The basic simulation. I'll give one such looking number to nums1 and I'll give one such looking number to nums2, right? So if, let's say, I'm maintaining a size variable, size1, and I'm also maintaining a size2 variable denoting the size of the current nums1 array and size of the current nums2 array, I can increment this by 1, right? Increment this by 1, and I can also increment this by 1, right? Because I'll be distributing that element x, one occurrence over here, one occurrence over here. So both sizes get increased by 1. And else, if this is case 3, meaning if fx is equal to 1. This is the only case remaining, right? We have covered the three possibilities of the frequency occurrences. So if fx turns out to be equal to 1, that means you only have one occurrence of that number. And if that is the case, you can either give it to nums1 or you can either give it to nums2. But what would make more sense? Where should I actually give this occurrence to? While simulating this process, whichever nums or whichever size of the array, size 1 or size 2, was lower, I should actually give this number to that, because I'm trying to make them actually equal. So I can greedily say that if case 3 falls into picture, I will check if size 1 is less than size 2, meaning size 2, that means in the current situation, nums1 array has lower elements I would have created than nums2, then I can be like, let me increase size 1 by 1. That means I'll give this x number to this nums1 array, increasing its size by 1, right? And bringing it closer to the size 2, or bringing it closer to the net size of nums2. And if that is not the case, then vice versa simply, I can say, yeah, nums2 array came out to be lower, then I can say, add 1 to nums2 array's size. And now, after coming out of the whole, I should say, frequency map I would have created of the whole array, right? After coming out of the whole frequency map, if after coming out of this, the simulation I just did, if size 1 became equal to size 2, correct? If size 1 became equal to size 2 as a check, that means I have distributed the elements in an orderly fashion, fulfilling all my conditions, right? That means I can return true. And if that is not the case, then automatically I'll return the answer false. All right, so this is what our code part will also look like for this question, right? So if you can see, I have created a frequency map over here, and I'll be inserting each number in the frequency map from the nums array. Now I'll create two variables, size 1 and size 2, everything is 0. So these denote the two sizes of the nums1 array and the nums2 array. Now I'll iterate in the frequency map. If it.second, that means the representation of the frequency of that xth number, if it turns out to be greater than 2, then you know I need to return false and false right from here. I don't need to go forward because that violates my condition directly. And if that is not the case, then if it.second is equal to 0, so because I need to balance both nums1 and nums2 in order of this x value, so I'll give this x1 over here, x1 over here. That means simultaneously I'll be increasing both sizes. So size 1 gets added on, size 2 gets added on. And if I go in the else part, that means it.second was equal to 1. And this became case 3. Now in this case, I can say if size 1 is less than size 2, then I increment size 1 by 1. And if that is not the case, then I increment size 2 by 1. Right? So I'll be doing the whole simulation like this so as to fulfill my conditions. I am indirectly trying to every time balance out the both arrays size, because my first condition also had to be fulfilled, that both arrays sizes turns out to be equal and also half of the original array. So when I encounter any number, I am giving it to the left side, to the right side also, or indirectly to the nums1, nums2 also. And if it only has frequency 1, then this is how I'm handling the case 3. I hope the concept has now become clear. And now after this, I can check a small statement over here that if size 1 equal to size 2, I can return out this value totally. So this returns true if both are equal, else it returns false. Right, a quick discussion on the time complexity. I am using an ordered map over here, right? So ordered map will have an average complexity of log n for all insertions, deletions, finding, everything. So I'm iterating on the nums array, right? So iteration is going to give me a complexity of n, and inside that I am inserting in the frequency map, so that gives me an added complexity of log of n. So this insertion is running in n log n, where n is the size of the array. Now again, I'm iterating in the frequency map, so this can maximum be in size of n, correct, where I can say all elements turned out to be distinct, and this is where things are going to end. So overall time complexity can be reported as n log n, correct, and this order definitely works for a size belonging to 100 range. Now as for space complexity, this is going to turn out as n size, because I have taken a map over here, and map size is definitely maximum worst case total of n. All right. So let us move to problem number 2. So let us read the problem 2. All right. it is written find the largest area of square inside two rectangles. So there exist n rectangles in the 2D plane, and you are given two indexed 2D integer arrays, bottom right and top right. Both are of size n, n cross 2, sorry, where bottom left I and top right I represent the bottom left and top right coordinates of the ith rectangle respectively. So it is written you can select a region formed from the intersection of two given rectangles, right? So this is important, and you need to find the largest area of a square that can fit inside this region if you select this region optimally. So you have to return the largest possible area of square, and you either, if that is not possible, then you return 0 if there does not exist any intersection between these rectangles, right? So if you carefully look at this diagram, you have bottom left and some top rights given, and they have drawn the diagram very precisely. So this is 1 comma 1 as bottom right of the first rectangle, and this is 3 comma 3. So this is the red rectangle extending from 1 comma 1 to 3 comma 3. Then the blue rectangle extends from 2 comma 2 to 4 comma 4, and the green rectangle extends from 3 comma 1 to 6 comma 6. So if you can look at any, let's say I can take the pair of this red and blue rectangle, then I can observe that I will have a 1 cross 1 square coming from the areas 2 comma 2 to 3 comma 3, right? Looking like this, where my pointer is running. So this is the maximum they can form. That is why they have written that a square of size 1 can fit inside this. By the intersection area of rectangle red and rectangle blue, you can say. Or even if you take blue and green, then also you can say that yes, a square is only fitting out of this, because the common area is actually this, but the small square part is of side 1 only. So the area turns out to be 1, and that is what is printed over here. Similarly, in this also you can see that yeah, I will have an area looking like this 1 over here in the intersection of, I can maybe take intersection of green and red, or I can take green and blue, or you can say red and blue also. Everything is going to have one maximum square area coming out of it, right? And for the last test case, they have written that nothing is intersecting. That is why you will have 0 as your answer. So I hope the question has been well understood, right? They are just trying to print common square areas you can cut off, and maximum out of all those possibilities for taking intersection among any given two rectangles, right? So now the first thing that will come to your mind is what would be the constraints of this problem, right? So technically, mostly on Leetcode problems, when you are encountering second or third problems, constraints are mostly lower, on the lower side, right? And this is what we are going to abuse over here too, right? I can see that n is an order of 10 to the power 3. So I will not think any further, right? There will definitely be some optimized solutions, but as for contest perspective, you can go ahead with a n square sort of solution, right? Why? Because you know, what do I mean by when I say n square solution? You know that you are trying to take any two given rectangles into consideration at a single given point of time, and then you are trying to calculate what is the common area among them. So to, let's say, make the pairs of I comma j, I'll be like, all right, I have a for loop with me, and I'll start it from 1 to n. So this will be an iterator I running from all the given rectangles. And for each ith rectangle, I'll try to pair this rectangle up to some jth other rectangle. So I'll be like, all right, I'll run a loop. This loop runs from maybe, let's say, I plus 1, right, and to n. And this iterator will be j. So inside the outer loop, running in a complexity of worst case O of n, and then I'll have an inner loop, right? And this inner loop also runs in worst case complexity, or in order of actually n, right? So this is going from I plus 1 to n. So kind of running in order of n. And inside this algorithm, I'll be able to extract the rectangle I, I'll be able to extract the rectangle j, and I can maybe pass these rectangles coordinates as values in some function, right? And inside that function, I can just pop out what is the intersection area, common intersection square area, right? So common square area, or intersecting area rather, right? Which comes out if I would have taken the rectangle I and rectangle j as two pairs. And if that is what, let's say, this common area turns out to be, let's say, a, then I can minimize this a with a global variable taken, and let's say maybe this is area is initially 0. So I can, maximize this value a. So I can be like, all right, whatever is the global area, that becomes maximum of the area itself, and this value a which pops up. And after this happens, I can just return this area value, right? I can return this area value and I can say, all right, this area value is definitely going to come out as my answer. Now to calculate the intersection area between the rectangle I and rectangle J would be mathematics, right? We'll also come up to that part and understand how will that mathematics work. But to understand this well is would be a good part over here, that yes, my constraints were given pretty low. So for a contest perspective too, or even generally I can say that yes, this will not give me TLE. In that perspective, I can create an n square solution, because now I know that the inner function calculation, since that would be mathematics, if I can reduce that down to O1 complexity, I can say that my overall algorithm turns out in order of n square. And since n is an order of 10 to the power 3, n square is going to work in order of 10 to the power 6, which is definitely going to get accepted. It's not going to give you a TLE, right? So this is what my approach over here is going to look like. I'll be iterating in 2 loops and extracting I and J rectangles, and then try to come up with some mathematics in constant time complexity if I can calculate what is the intersection area among them. And then if I calculate the intersection common square area out of that, I can pop that out value as A, and I can maximize that value A with a global area variable I wanted to return. And this overall code can then work in an n square complexity. All right, so this is what the crux of the problem is trying to tell you. It's a very simple implementation based problem. You have to not think very deep, right? So if you quickly look at the core part of this, all right, so let's not for one moment discuss how are we actually calculating the area. Besides that, this is going to look pretty simple. As discussed, you have the maximum area. You can take that out as 0, and then you can have that, all right, I have n, I have bottom left dot size, I can extract that out. So that is the n number of rectangles given to me. And then I can run an iterator, I0 to I less than n, and then j runs from I plus 1 to j less than n, right? So I'll be running 2 iterators to extract the pairs I comma j, right? And then I can print that, all right, max area turns out to be maximum of, let's say, max area, comma, then I'll call this function and I'll be passing the values. So up till here, I'll be passing the values of the bottom right I, top right I, means I'll be passing the coordinates which were given to me to represent rectangle 1. And then I'll be passing bottom left j and top right j to represent the coordinate rectangles, or the rectangle, typically rectangle j, right? And then whatever pops out the value out of this function can be reported as my value A, and I can maximize this with this max area variable, and then I can return this variable. Initially this is 0, so if let's say nothing gets intersected, then I know 0 is going to get returned, and you can see this gets accepted, right? So all is left to do is discuss what is our mathematics behind actually calculating the intersection areas. All right, so what I have done over here is, in very simple terms, you can definitely bifurcate the whole mathematics into your own analogy and maybe try to figure out, yeah, I can have various cases, you can put more if and checks and everything, but mathematically, everything is going to get boiled down to very short code over here, right? What I have done over here is, x bottom left and y bottom left typically denote the x and y coordinate of the square I would have tried to create, right, in the bottom left side. So let's say I have the rectangle, one rectangle coming over here like this, right? And then I have one rectangle coming over here like this. So my target is to actually calculate that, yes, this would have formed the square, right? This would be the square area that would be coming to me. So my target is to actually calculate what is going to be this coordinates x and y, correct? And I'll try to calculate what are these, I should say, coordinates x, and these are these coordinates x and y, correct? If I'm able to calculate this, then I can say, let's say this is, and I have named them typically. So this is x bottom left, y bottom left, and this is x top right and y top right. And after this, I can put very simple checks on these two coordinates. If let's say they are actually able to create an area out of them, then I can take whatever is the, I can say, I should say, like, let's say this turns out to be the distance in the x coordinates, right? This turns out to be the distance in y coordinates, or typically I will have some width, correct? I'll have some breadth. And since I know I'm trying to take a square area chopped out of the common intersection, so right now I only have calculated the, I should say, x and y coordinates of the intersection area. So this is x and y coordinates of the bottom left side of the intersection area, right? This was the intersection area, and this is x y of the top right intersection area. And out of this intersection area, let's say I'm once I do that, I'll be easily able to calculate the width and the breadth of that intersection area. So because I want to extract a square area out of that, so I'll be like, whatever is the minimum out of these two, is going to represent the side of the square. And let's say the minimum out of these two turns out to be width. Let's say for example, then I can say, all right, like let's say this width over here is the minimum. Then I can say width cross width is going to be the area of this square, right? Else if it is breadth, then I can say breadth cross breadth turns out to be the area of the square. And then I can return that area and I can be like, yeah, that is going to get maximized later on with my max area variable. Now, the whole thing is, how do we actually do this? How are we actually calculating x comma y and for the bottom right and x comma y for the top right? All right, so this is pretty mathematics, right? This is pretty much mathematics. What is actually given to you over here is, I'll generalize cases over here. What is actually given to over here is, let's say this is, these are the two rectangles. I'll change the pen. So these are, let's say, the two rectangles, right? So what is typically given over here is, you are given this coordinate, all right? You are given, I'm passing these coordinates and this coordinate, and for the blue part, I am passing these coordinates and these coordinates, right? So what I know that I am taking I comma j as the rectangles. So I'll try that, right? This is the jth rectangle, this is the ith rectangle. So naturally, if let's say I am trying to figure out what is the intersection out of these two, right? So if let's say I'll try to talk first in the x direction, right? I'll try to talk first in the x direction, right? X direction, and then I'll try to figure out what is in the y direction, right? So I'll bifurcate this into two parts. So try to imagine the x direction, all right? What can happen over here is, in the x direction, what can happen is, you will first talk about the two bottom left points of this I and j rectangle. So this is point number one. So this can be point number one, this can be point number two. Now imagine this point number one and this point number two, right? Naturally, in this case, you can clearly observe that in this case, the intersection of these two rectangles, or the intersection area of these two rectangles, my target was to find the intersection. If I have this intersection area coming out to me in the black portion, what is the bottom left x coordinate of this intersection rectangle? Correct, intersection area, to be very specific, right? So definitely this x coordinate over here is turning out to be the maximum, or typically in this case, it is turning out to be the coordinate x of this jth rectangle's bottom left, right? And this is going to change only and only when, let's say, you imagine that you are moving this rectangle to the left hand side. All right, so let's say you are moving this rectangle to the left hand side. So this whole blue rectangle starts moving to the left hand side, keeping the y direction constant. So maybe this typically falls over here, you have the blue coordinate coming over here, then maybe it moves over here, blue coordinate coming over here, then moves over here, blue coordinate coming over here, and then maybe it crosses this line, and then the whole blue rectangle now actually is like placed like this, right? Placed like this. Am I right? So in that case, what is now typically going to be the x coordinate of the common area? The common area is going to extend like this. This is what is going to be the common area, right? So this is what is going to be the coordinate. This is what is going to be the coordinate of this bottom left x coordinate of this common area. And now this bottom left x coordinate is actually the x coordinate of the ith rectangle's bottom left x coordinate. Am I right? So what is happening over here is, in either of the two cases I just showed you, either it can happen that jth rectangle falls after I, or the jth rectangle's x coordinate falls after I, or if it falls before I. If it falls after I or it falls before I, the intersection area's x coordinate is turning out to be maximum of both the x coordinates, right? So this is what I have written over here. I am calculating x of bottom left, right? This is the intersection area's bottom left x coordinate, and this is going to look as the maximum of the rectangle 1's bottom left and rectangle 2's bottom left's x coordinates. So at the 0th position, I'll be having x coordinates. So this is out of the both max values, x bottom left is going to have that value. And by similar analogy, if you try to imagine that I would be moving this in y directions, then because I want this coordinates yth part of this coordinate, then I can be like, this can happen that j comes above I, a jth rectangle comes above I, maybe jth rectangle comes below I. In all cases, if you try to draw the rectangles yourself on pen and paper, you will observe that whatever is the maximum out of these two coordinates is turning out as the intersection areas y bottom left, or bottom left's coordinates yth value, yth position. Right. And now by similar analogy, once I have calculated the bottom left part, bottom left, I should say coordinate, this coordinate, bottom left coordinate of the common area intersection, then my target becomes to calculate this. And when I'm trying to calculate this, carefully observe that things become reversed, right? Right now I was taking maximum of j and ith rectangles x and y coordinates, but now in the bottom left direction, but because now I'm talking about in the top right direction, so even for, let's say the previous case I just draw that you have this rectangle and you have this rectangle placed like this. In this case, you can clearly see that if I talk about the x coordinate, I'm trying to calculate this coordinate, right? So this coordinates x value. This coordinates x value is actually the red rectangle's x value of the top right portion, right? And why is that? Because it is the minimum out of the ith rectangles or the red rectangles top right x coordinate and the jth rectangles, blue rectangles top right x coordinate. So whatever x comma y is placed over here and whatever, let's say, x comma y is placed over here, or maybe you can call this x1 y1, I can maybe call this x2 and y2. So minimum of x1 and x2 is actually equal to the x coordinate of this particular top right, and whatever is the minimum of y1 and y2 by similar analogy will turn out as the common the intersection areas top right y coordinate, right? So this is the similar analogy by the max function. So for calculating the top right thing, I'll be doing a minimum on the same coordinates. So this becomes minimum of r1 top right 0 and r2 top right 0. So comparing the taking out the minimum of the x coordinates of the top right of the two rectangles and taking out the minimum of the y coordinates of the top right values in the two rectangles, and that becomes my x top and y top. And once I have found that out, I can be like, all right, I have this coordinate over here, correct? I have this coordinate over here. This has the value, and I have this coordinate over here. So this is what my intersection area. This is what my intersection area is popping out to be, right? This is what my, or actually, rather I should actually draw like this, right? This is what my intersection area is popping out like, right? This is what my intersection area is popping out. So once I have calculated these two sides, these two coordinates, I can put a small check, right? So I have, let's say this is x1 comma y1, and this is, let's say, x2 comma and y2, right? So I know I have calculated the x coordinates and y coordinates in such a manner that x2 is definitely falling after x1. So if x2 minus x1 is turning out to be greater than 0, and y2 minus y1 is also turning out to be greater than 0, because I've created coordinates in such a way that I know if there does exist an area, a positive area of this intersection area I've just found out, then x2 minus x1 will turn out to be greater than 0, and y2 minus y1 will also turn out to be greater than 0. That means there will be some gap in x2 and y2, and there will be some gap in the positive direction from going from y1 to y2. And if that is the case, that means yes, there has been chopped out some intersection part of these coordinates I just calculated. And if that becomes the case, so I can put an if check that if top right is greater than x bottom left, right? X top right is greater than x bottom left, or that means x2 minus x1 is greater than 0 indirectly, right? And if y top right turns out to be greater than y bottom left, then I know I can calculate the side, because there does exist an intersecting area. Now I can find out that, all right, this intersection area looked like this. I need to extract a square out of this. So greedily, my maximum square that can be extracted out of this rectangle would be, or this intersection area would be, in this case, this looks like a rectangle, would be that I can take the maximum, the minimum difference out of the width and the breadth. So this would be the width, right? In the blue pen I'll draw, this would be the width, and in the red side I'll draw, this would be the height, correct? So this would be the breadth and this would be the height, whatever you can call this, terms don't matter. And out of this, the minimum is turning out as the blue portion. So I can figure out that, yeah, this blue portion is actually x2 minus x1, and then I can square that out, the value of x2 minus x1, and that can be reported as my side of the the area of the square, because what I would have done is I would have taken this blue side and I would have covered a square out of this, right? I would have covered a square out of this. All right, so this is what I have done over here. So if the conditions check out, then I can be like, whatever is the minimum of x top right minus y bottom right left and y top right minus y bottom left turns out to be the side of the area, side of the square, sorry, and side cross side becomes my area. And if this condition is not fulfilled, means although you did try to find the intersection area in the ing rectangle, they did not chop out a positive area to you. And if they did not chop out a positive area to you, where will you actually find a square out of that? No, that's not possible, right? So you can return 0 outside this if check. All right, and then once you understood that yes, mathematically this is definitely giving me the accurate result for I and j rectangles as intersection areas, I can then common square intersection area, then I can figure out that yes, this is what is going to get popped out of this function as well, and maximizing that value with the max area variable gives me my final answer. All right, so the crude idea to understand is this is a very implementation based question, and we can quickly discuss the time complexity. So as I said, this is definitely running in n square time complexity. Why? Because I have two loops, 0 to n, and in an order of n again inside the inner loop also, and everything in the function is getting calculated in a constant time complexity, right? And as for space complexities, this is definitely time complexity. This is time complexity. And as for space complexity, you can see that I am using no other variables, right? Everything is no data structure is used. I am using simple variables to calculate everything. So space is definitely constant. So I can write space is constant and time complexity is n square. Now n square complexity is definitely 10 to the power 6 order. That is why this is going to work. All right, so let us now try to move to the third problem. So we begin with the third question, right? The question is named earliest second to mark indices 1. So this is part 1 of the question. Similarly, they have given the part 2 also, right? So you are given two 1 indexed integer arrays, right? And nums, one is called nums, one is called change indices. Both have lengths n and m respectively. So initially all the indices in the nums are unmarked, and your task is to mark all the indices in the nums vector. So in each second s, that is in order from 1 to m inclusive, you can perform one of the following operations. You are said that, all right, when you are performing these operations, you in that second, you either do out of these three operations, right? Either you choose an index I in the range 1 to n and you decrement nums of I by 1, or you can check is nums of change indices of s, that is the th second you are currently in, is equal to 0. And if it is equal to 0, then you will mark that index change indices of s. And third option can be you do nothing. So the question is asking you, you will return an integer denoting the earliest second in the range 1 to m, where all indices in nums can be marked by choosing operations optimally, or -1 if this is not possible. All right. So question is pretty clear over here. If we quickly look at the test cases, you have, let's say nums is 2 to 0 and change indices is 2 2 2 2 3 2 2 1. So they've given a small explanation of this. Let us quickly read this out. Let's say you are choosing index 1 and you will decrement nums by 1. So this is in the second one. Second one, it is telling you that it would be optimal to choose the index 1 and decrement it by 1. So I'll choose the index 1. Correct, this is index 1 and I'll decrement it. So array now becomes 1 to 0. Next time I'll choose it again, it becomes 0 to 0. Next time it becomes 0 1 0, and next time it becomes 0 0 0. So after the fourth second, now I can go to the fifth second. In the fifth second, I'll mark the index, change index of 5. So change index 5 is 3. So I'll be marking the third index, and third index is indirectly dissolved, or you can say it's marked, right? It's done and dusted. Now you will be like, all right, in the sixth second, I can mark the index number 2, because at change index of 6 I have the value 2, so I'll mark index 2. This also gets marked because this is equal to 0. So because they are equal to 0, they have the possibility to be marked. And now seventh is do nothing, and in the 8th second you will mark the index 1 that was left. And after this, after 8 seconds, you know that in 8 seconds you have been able to reduce the whole array to 0 0 0, and you have successfully marked the indexes as well. So you know that answer can be reported as 8, and they have claimed that it is not possible to mark all the indices earlier than the 8th second. So that is why the answer is turning out as 8. All right. So what is actually the crux of this question, right? You are trying to minimize the number of seconds in which you can actually perform such operations. And to be very specific, by what I mean by performing such operations is reducing each number. So first target becomes that you are reducing each number to zero. And what is the second type? You are also simultaneously able to mark all indexes reduced to zero, right? These two targets are what you're trying to fulfill, and you're trying to check that in how many seconds from the range 1 to m, what is the minimum number of seconds I would require as a value which can be reported in the seconds 1 to m, for which I can say that, right, this is going to be this can be written as my answer, and this can be said that, yeah, in this number of seconds minimum, I will be able to fulfill these two targets, right, by taking the operations into count. I'll be reducing the whole array of nums to zero, that is each number becomes zero, and in some other available operations, I'll be also marking those indexes as the marked indexes because they have been reduced to zero. All right. So now the crude idea over here to understand is what are we trying to, like, what time complexity are we trying to achieve, right? Or mostly in these questions, typically Leetcode 3 and Leetcode 4 problems can be well understood with a general look at the constraints, right? So you see that n is given in 2000, right? And m, that is the chain indices length, is also given in a range of 2000. So what would be optimal over here, right? Maybe an n square solution can work, right? Maybe n square will work because you will go in order of 10 to the power 6. M square will also work. Maybe n into m will work, or anything below that also works, right? Anything below that also works. So my target is to maximum go in n square limit, right? My maximum limit is to go in n square, maybe m square, maybe n log something, right? And anything like this will definitely work. All right, so this is first intuition that my time complexities are looking in such a way. And because I'll try to understand that, yeah, n square, m square, n log n was working, maybe I can figure out some solution which is going to work in these time complexities. So first thing to note over here is expected time complexities. Next thing is to understand is you are trying to minimize some value in a given range, right? So my next intuition can go is what is the actual function, what is the nature of the function on these values of the earliest second? Meaning they have talked about seconds, right? So let's say you are talking that I have 1 second, I have 2 seconds, I have 3 seconds, I have so on till m seconds. All right. So let's say you say this second over here, kept over here, let's say this x second was my answer. Optimally, let's say I know beforehand that x is going to be my answer. So what is the nature of this function that is created by these values, right? What do I mean by this nature? What if, let's say, argument becomes over here is, if let's say in x seconds, knowingly, if you know that in x seconds you are able to fulfill your targets in the array, that is marking all the values as well as reducing them to zero, you are able to do that in x seconds. Will you or will you not be able to do the same result, or will you not be able to achieve the same targets in the seconds x plus 1, x plus 2, x plus 3, and so on till m? Is that right? If let's say in x seconds you are able to achieve your target of doing these two values, you will obviously be able to achieve that target in the upcoming seconds, right? So that means the nature of these seconds values, or the nature of this function, is increasing, or to be specific, it is monotonically increasing. All right. And this is where I can say that, yes, I can form a binary search sort of a solution. That means I can binary search on the seconds value. I can run an L pointer from, let's say, 0, and I can run an R pointer from, let's say, M, and or low and high to be specific, and then I can binary search on the answer. I can first figure out that, yes, this x value is going to come out as my mid value, and then I can fixate that if I would have required to find is my target able to achieve, are my targets able to achieve in the fixed x second passed as the mid value. If it turns out to be true, then I can be like, then this becomes one of my potential answers, and I can reduce my high. If let's say high is kept over here, low is initially kept over here, then I can reduce my high to mid -1 value. Or to be specific, I can, if I'm using high and low only as a technique, I can bring high to this mid value. So if this is mid, I can bring high to mid value, because I know I don't need to check beyond this mid values, because if mid was possible, or if is possible function for the mid value became true, I am definitely able to achieve in the seconds coming after mid. So I don't need to check any further. And since my target is to minimize this mid value, or minimize the number of seconds I'm able to achieve my target in, I'll be bringing high to the left hand side. And if is possible of mid turns out to be not true, that means all the seconds below x are also not possible. If you are not able to achieve your target in h seconds only, would it be possible for you to achieve your target in lower than x seconds? No. So then you need to bring your low to the forward position. So my intuition over here revolves around the binary search concept, right? Why? Because I am able to observe that yes, the seconds values are actually a monotonically increasing function. Up till a mid value x, below that answers are not possible, and after that all answers are possible. So I can binary search on that mid value, I can binary search on the seconds value, and then figure out how can I actually proceed forward. So once I'm able to understand that, yeah, binary search is going to work, I know that for writing that binary search logic, it is going to run in log of m complexity, right? Log of m complexity. Why log of m? Because m is the total seconds I'm talking about, right? So binary search is definitely running in log of m. And inside this binary search, I will have some function, right? I'll have some function which is going to return true and false according to the passed mid value. So now, since I have already covered a log m complexity, and since m is an order of, I should say 2000, right? In order of 2000. So that would mean that this function, this inner function that I'll create to actually check is mid possible or not, then this function should run in complexities of, I should say order of n would be a good function, right? Because why order of n or order of m, maybe something like that. Because if that is the case, then I will be able to achieve a good complexity looking like in some sorts of n log m or m log m, whatever I try to form, which is indirectly trying to say that my target of receiving a complexity in is order of 10 to the power 5 to 10 to the power 6 will be fulfilled. So this gives me an intuition that my inner function, I can maybe try to optimize my inner function and try to think of a logic such that my inner function runs in O of n or O of m complexity. That gives me a suited time complexity and everything looks within our boundaries. So next target becomes this, yes, I have figured out that binary search is the logic to go ahead. How do I actually create this inner function? I have is possible, if I name this as is possible. How do you pop out true and false according to this value mid you have passed? If you would have said that let's fix mid as seconds, tell me, is it true to achieve your target in this mid seconds, or is it not true to achieve this target in your mid seconds? All right. So the analogy over here is, the concept over here would be, the idea would make that, let's say you have some mid seconds with you. All right. So let's say you figure out that up till seconds 5. All right. Up till let's say maybe seconds 5, I am checking, is it possible not? Is it possible or not? So what I'll do over here is I can mark whatever is the last index position of each change indices. All right. So in my array, let's say I can create an array of last. All right. Size can be n, right? Size can be n. And then I can be like, let me mark last of change indices of I equals to I. So what am I doing over here is I am saying that I will first mark that in these change indices values, what is the last index of each value. So I know that if my limit is over here, the blue portion, then the last index value of 3 is 0, 1, 2, 3, 4, 5. If let's say I am taking 0 as indexing, and the last index value of 2 is 0, 1, 2, 3, 4. From the backhand side, I will first store the last index. What am I trying to do actually over here is, I am trying to delay the marking of each indice in the nums array as late as possible. Why is that? Because if I try to delay the marking of each indice in the nums array, I can use the other seconds which came to me to actually reduce the ith index by 1. Because remember, your target is that you will only be able to mark that index placed at change indexes of S if that value is 0. So if let's say you delay as long as possible to mark some index to 0, all the operations before, all the seconds that have passed before that second, ith second, where you marked the last position of change indices of S, those seconds can be used to decrement nums of I by 1 greedily. So that would mean that if from the backend side I mark what is the last position where after which I cannot operate on that specific index. So I know that after the fourth index, if let's say my range was from 0 to 5 in this case, 2, 2, 2, 2, 3, this is the number of seconds I'm talking about. In these 5 seconds, the last second I can actually operate on the index 2 is second 4, correct? Second 4. And the last index I can operate on the second 3 is actually at second 5. So all the seconds before those seconds can be dedicated to actually reduce these second values if they had some value left, because my target is to reduce them to 0, and only after they get reduced to 0 is when I will be able to mark them. So before position 4 and before position 5, seconds 1, 2, 3 can be dedicated to actually reduce these values as possible. So my function can look like, after I have marked last change indices of I with equal to I have greedily said that this is the final index I will be working on change indices of I. And before this, I can, for this marking is definitely going to run in O of mid complexity, right? O of mid complexity. Mid is whatever seconds I have passed inside this. So I'll be running a loop from indexes 0 to 5, let's say, right? Or 1 to 5, whatever you can say, 1 based indexing for passing that index. So complexity for this turns out to be O of mid. So this is the is possible function, right? I'm discussing with you the is possible function. So I've passed some mid in this and I am trying to check, am I returning true and false? Now, once I have marked the last and portion, I can take two variables. One can be called as marked. This is the count of marked indices up till now. This starts with 0. And then I have the other variable. I can call this variable as operations. All right. So this is the operation means this is also 0. Operation means the number of operations of the one time that are available to me, which give me the power to reduce any index by 1. All right. Any index's value by 1. So I can now run a loop again, right? This loop is again going to run in the mid seconds, I can say, right? And inside this loop, I can say that if currently the ith second I'm standing at, is this ith second equal to last of change indices, indices of I, and maybe I can pass this as I minus 1 also, right? This can be minus 1 because I want a 0 based indexing. So you can, and the change indices are given you in 1 based indexing. So you can take a 0 based indexing over here, right? So now you can say that if my current ith index is equal to the last index I marked in the change indices. So that is the last position I can go up till to manipulate this ith index. And because this is the last position I can go, I have to now check right over here that up till here, the available operation count with me, which denoted the operations of the one type, is the available operation count with me available up till here, is it actually greater than equal to the value kept at change indexes of I minus 1? Because if that is possible, if it is kept, so inside this I can check that if operation count is greater than equal to nums of change indices of I minus 1, right? If that is the case, that means I have some available operations with me and I can dedicate those operations that came in the previous seconds. I can dedicate those operations to reduce this nums change of I minus 1 value to 0, because the available operation counts was greater than equal to this value. I will definitely have enough operations to reduce this value. So inside this, I can greedily say that let me reduce this nums of changes of I. This can become equal to 0, and simultaneously operations can be reduced. Operation gets reduced to whatever new count they become after taking into consideration that nums of change of I minus 1 has become 0. Nums of this can be nums of change of I, right? Change of I becomes 0. Change of I minus 1 actually becomes 0. And then operations can be reduced. And if this, and I can now increment marked variable as 1, because I know that because they have become 0, before this available operations helped me to change this num's value as 0, and then in this ith second I can dedicate my operation number 2, I can dedicate the this second line to this ith second, and I can mark this indice as 0, right? I can mark this indice totally as in my answer. So my marked variable gets added on with one value. And if that is not the case, if I can say that this is else, if this is the else part, that means the available operations up till here, I was delaying as long as possible. But even then, the available operations with me of the type 1 were not enough to change nums of change the value in nums of change of index -1 position to be 0. And if that is the case, I can directly return false from here. I can directly return false from here because I know I did not have enough operations to actually, I could have changed this value in this enough operation count. That means this second is not possible. I cannot achieve my answer. I cannot achieve the answer of reducing each index to 0 as well as marking that index in some in this given mid seconds I have taken. So I can return false directly from here. And if that is not the case, that means if the ith second I'm talking about is actually not the last position where I could have actually operated on this index, then this becomes the else part of this if part, right? And in else, I can say if this is not the last index, then I can use or dedicate this second, dedicate up till here this ith second to actually store this as an operation. So I can increment operation by 1. And later on, this operation can be utilized if I was actually equal to last of change of indexes I minus 1. Right? So I hope the logic has now become clear. And all of this stuff I am doing over here is going to definitely run in complexity of O of mid. Is that right? So when I'll be coming out of this loop, I can write this on next page. When I'll be coming out of this loop, I definitely have a variable marked with me, right? And what was the target? My target was to mark total of n values, right? N is the size of the nums. So I can simply check, is marked values equal to n? If marked value came out equal to n, that means I was able to successfully mark total n values in the nums array. And if I was able to successfully mark total n values in the marked total array, then I know this is a true case, because that means in this given mid seconds I was able to achieve my result, else this becomes the false case. All right. So this is what my crux logic is going to look like. So if we can convert this out to code format, you will be easily able to understand what am I doing over here. All right. So before going to the isPossible function, you can see that, yeah, it's a very simple binary search. I'll take n nums size m change indice plus dot size. Now what I can do over here is I can declare my low to be 0 and I can declare high to be m plus 1. All right, so this is a very small trick over here. Why am I declaring high to be m plus 1? Because the maximum seconds I can go is m, and if I go beyond that, then my answer would have definitely come out as maybe 9 or anything above 9. Not 9. I'm just saying 9 because I have in my mind the first case. Typically this generalized case would be change indices.size plus 1. So high can be declared as m plus 1, and later on you start with a binary search. You declare that, all right, this is actually futile. All right, I don't need to, I can work in low and mid only, low and high only, and then I can write binary search. If while low is less than high, then I can first calculate mid value. This is low plus high by 2. And then I can pass this mid value as the number of seconds I would have fixed in the isPossible function. So I'll pass nums, change indices, and mid inside this. And if this turns out to be true, so if this gives me a true value, that means this current mid that I calculated was actually a possible or a viable answer. So I can bring high to mid because I know it's monotonically increasing. So every value after mid is definitely going to give me true result. So I can bring high to mid, and I can keep processing my binary search more and more. And if this was not going to give me true, that means the current mid seconds I fixed was not sufficient. So anything below will also not be sufficient. So I can bring low to the forward position, that is mid plus 1. Now definitely you can very clearly observe that the answer is getting stored in the high variable, right? And because it is getting stored in the high variable, I can then put a small check. If high is equal to m plus 1, that means I have closed the limit. the maximum seconds I was talking about was in the range 1 to m. And if the answer actually came out as m plus 1, that means I need to return -1, because in the given range of 1 to m seconds, the maximum seconds I could have gone is m. And in m seconds also, I was not able to achieve my answer. That is why my high value would have stored a value that was m plus 1. And if that became the case, it would have ended the binary search on m plus 1 value. That means I need to return -1. I was not able to fulfill my targets in the given 1 to m range. And if this if check condition doesn't become true, then I can return high as it is. That is definitely going to give me the correct minimal number of seconds in which I fulfilled my target. All right. Now, if I look at the isPossible function, I'll be passing nums, change indices, and seconds. Now I will extract the nums size, so this is n again, and then I'll create a last array. Size is n plus 1, and this is -1. Initially, everything gets marked with -1. So what is it actually storing? It is storing the last indice value of every up till in the seconds limit. So I'll be running a for loop 0 to seconds, and in change indices of I minus 1, why I minus 1? Because I know this is 1 based indexing. I need to convert it to 0 based indexing. I'll mark last of change of indexes of I minus 1 as I. So when this loop ends, in each index of last, I'll be storing what was the last from the backend side in the change indices array, where I could have actually operated the second type of value, second type of operation in the marking sense, right? So before all those indices, all those seconds are free. So I'll make two variables, marked and operations. Everything is 0. Run a loop from 0 to seconds, and then if ith second is actually equal to the last change of indices I minus 1, then I know that I need to now. I will have to necessarily check if I can mark this indice or not, because beyond this, I don't have any position where am I actually able to operate on this index. So I'll check, is nums of change of index of I minus 1 greater than operations? If that is true, that means my available operations were not enough. So I need to return false. This becomes my case over here. I just showed you that you have to return false if this condition is not true. So indirectly I've written that is operation lower than the value. And if that is not the case, then I can deduct from my operations this value, which would indirectly mean that I have converted nums of change index I minus 1 to a value 0, right? Changed to 0, and I can increment marked variable by 1. And if this condition is not fulfilled, that means I am standing at an ith second, which was futile to me. I can actually try to use this second to store it in an operation format for the first type of operation, where I will greedily store this and say that I will use this second, or I could have used this second to actually decrement nums of I. So I'll increment operations by 1. Right now I can check is marked equal to n. If that is true, that means I have marked all the indices in the nums vector. That was my target. So this returns true, else this returns false. Alright, so now we can quickly discuss the time complexity. This is definitely a binary search, right? Running in log of m complexity. Why? Because you can see low and high are in 0 to m plus 1, correct? And inside this, I have a isPossible function. Now, if we discuss the isPossible time complexity, this is seconds. This is running in order of mid, correct? Order of mid. And then I have this also running in order of mid, right? This also runs in order of mid. And then everything is looking pretty constant, right? So everything is getting figured out in constant time complexity. So I can say that overall this binary search is running in m log m complexity, right? Because average case this will be log m, and inside this maximum I can maybe pass for check for m total m seconds, maximum m seconds. So this runs in m log m complexity. Now since m is an order of 2000, right, 2000, so this is definitely going to work, not going to give me a TLE at all. So I can write that yes, time complexity is in m log m. Now as for space complexity, since you know inside the isPossible function I am using an extra vector called last, which is for the marking of the indices, last possible indices, where I could have operated on the second type of the actual marking to 0 operation that is given to me. So I know space complexity is turning out as O of n, because n is the size of the array I have taken inside this function. Besides this, I'm not using any extra data structure to calculate anything. Everything is pretty constant. So space can be reported as O of n. So this brings us to the end of the third problem.